Hey, also, I get a lot of questions about excavations, especially when it comes to non-one-to-one slopes. And so this could be for trenches or larger excavations. I wanted to talk to you a little bit about a basic symmetrical excavation here, where we have a known depth, which we're going to consider to be the average depth here. And then there's some base, it's trapezoid, right? And some points of concern or interest are the half depth points, the average width, the um, vertical and horizontal components that help to define the angle of this trench. And then, of course, we have the half width here for the cutback, right? This would be the cutback at our slope. Again, this is just a regular old slope. It's not stepped or staired. You have a workspace here of some dimension. You have your structure, and I've reproduced the average width here as well. So why do we care about average width? Why don't we just go and look at this as a trapezoid? Well, because we might not necessarily know the actual upper base here for the trapezoid. We actually have to define that. So you can pause this and read through my little notes here if you'd like. But I did want to talk about how average width, which is an important value for us, is a function of depth and slope. But before that, I really wanted to point you to the code. So let's take a look at OSHA.gov. And this is part 1926 on excavations here for sloping and benching. So as you go through and you read this, you'll notice that OSHA defines maximum allowable slopes based off of soil classifications. And we'll talk about some of these today. And primarily I'm concerned with longer term exposure for these slopes. But again, you can look at OSHA's regulations on maximum allowable slopes, and you'll see that they are reported in ratios of, again, horizontal to vertical components, with the vertical set to 1, and then you can go from straight up, which is 90 degrees, through about a 30 something degree angle, right? 34-degree angle, something similar. And so this is a changing steepness. So rock is very, very stable, as you can see here. And so a rock face can be set up vertically and it'll support itself typically. Again, that's the maximum slope. It wouldn't make much sense to go past 90 degrees. You wouldn't want to dig in because then you have the shear or the cave-in risk, okay? So anyway, same thing here. This is all about safety, and there are certain regulations here. OSHA has some pretty decent little simple drawings on these, and we know from in reality that things aren't perfectly geometrical in an excavation, but it gives you an idea of some of the range on how these excavations can be sloped and what those ratios look like, and it also sets you up for the requirements. Okay, so I won't spend too much time on this. I just wanted to show you where these ratios come from, and we really will focus primarily on table B1 with those maximum allowable slopes based off of soil type. So let's take a look at this calculator again. Wanted to show you a little bit about these soil types and the ratio. So let's say these are horizontal to vertical components, which you might not be familiar with horizontal to vertical as a way of reporting slope. You might think of rise over run, which is vertical to horizontal. So be very careful on that as you're interpreting it. But if we set, let's say, 3/4, so it's 0.75 to 1, we're looking at a 53-degree angle, which is in agreement with table B1. If we're looking at a 1-to-1, we're at a 45-degree angle. If we're looking at a type C, a 1.5 to 1, and you see it's just about 34 degrees. So they went conservatively higher because that would be, well, they rounded up. I don't know if that's conservative, but they rounded up to a close approximation. And so as you go through, you can get some kind of a sense for how the different ratios change the angle, because it's easier for us to understand maybe a 63-degree angle, a 60 or a 70-degree angle versus a half to one. Okay? So I just put that there just to give you an idea. But either way, we want to figure out how slope relates to average width. So I'm glad you asked. Basically, we're looking at this average width, and the steeper the slope, the smaller the width contribution for that dimension. Okay, so for the dimension of the height. And so if it's a more shallow slope, then if we take the ratio here of half of our horizontal component, then it's going to contribute much more to the average width. So the average width is going to basically be half of the horizontal, right? Because it's halfway down here, or not quite, but the general idea. It's some component here down the vertical. And so we have that times 2, because there's 2 of them on either side. Add to that twice the workspace, because there's 2 on either side. And then whatever structure you have going on in here, whether it's a large basement excavation or foundation wall, something, whatever your setup is going to be. So I give you some examples here because this is really what catches people up when they're doing these calculations. So if you have a horizontal to vertical of 1 to 1, then the height is going to be that average depth. So half of the height is going to be half of the depth. Relatively simple. If it's a 1 to 2, then you have the height being half of the depth. By definition, it's 2 vertical for every 1 horizontal. So h over 2 is going to be half of that, right? This is the average depth divided by 2. So it's going to be the depth over 4. So 1/4 of the depth is this little value that we're adding in to the average width to get the average width, actually determine what it needs to be based off of the slope regulations. If it's a 1 to 3, right, really pretty steep, so not really something that's covered right here unless we're considered stable rock. But anyway, if it is 1 to 3, then you have the height being 1/3 of the depth by definition, because it's 3 vertical for every 1 horizontal. And so h over 2, this small component or half component that gets added into either side, is going to be, if that's d over 3, then half of that's going to be d over 6, the average depth divided by 6, or 1/6 of it. Okay, so you can see again, steeper the slope, smaller the width contribution. It's getting much steeper here, and so this denominator is getting larger. It gets larger, the overall value gets smaller. Great. And I gave you another example here, a 1.5 horizontal, just to show you what a type C would look like. That would be 3/2 height for every 1 vertical. So again, we're considering vertical to be the average depth here, right? Equivalent. And so h over 2 is going to be not 3/2, but 3/4 d, etc. So you find it, you double it, like I showed you, because you're adding on both sides. You add it to double the workspace here, whatever that value is, 1 foot, 2 foot, whatever it's going to be. And then you add in the structure width. Okay? And then you've got your average width. And then you're able to use that average width in your later trench calculations or excavation calculations. So, yes, it's a trapezoid. That's great. That comes in later on when you're looking at volume calculations. But if you do not know already this upper calculation, then you need to determine it by finding the average width based again off of the CFR, based off of our OSHA code, OSHA regs. So you can try this. Let's say that the structure, the base is 20 feet. Workspace is 18 inches, so that's 1.5 feet. And then the average depth, we'll say, is 4.5 feet, 4.5 feet. So we're saying that the soil type is A. So that is, here we go, 3/4 to 1, or 0.75 to 1, horizontal to vertical. So the horizontal is less than the maximum, or the average depth rather. So horizontal is 3/4 D. So this H2 component, half of the horizontal, is going to be 3/8, right? That's 3/4 times a half, or 3/4 divided by 2. 3/8 of the average depth, and then just carry that through. So average depth is 4.5 feet times 3/8. That means this is going to be this value, more than 1.5 feet, times 2, because we're adding it to both sides. It's this value. Add in 3 feet for the workspace, 1.5 on either side, and we get this. And then we add in the base width. And so when we resolve this into feet and inches, we have it comes out to 26 feet, 4.5 inches. And that was the average width for the excavation. And again, you can use it. So remember, this has a purpose. It's not just volume calculations, and it has a source, and that would be our OSHA regulations. Sound good? Okay, trench and excavate safely.